I've always wondered a question. How does the area of a parachute affect the amount of time taken for it to reach the ground? Well, my doubts will be answered because today I'll be conducting a fun experiment where I'll find out how the area of each parachute will affect the time taken for it to reach the ground. Below are the materials used for the experiment. I have 5 boxes made of the same material but of different sizes. These boxes will represent the paper parachutes, and these boxes will be brought from the same height, and I will measure and take down the time taken for each box to reach the ground. Well, if you're wondering why do I have blue tacks and a weighing scale, the largest box has the greatest amount of mass, as has the greatest amount of material, while the smaller boxes will have a lesser amount of mass, as it is made of lesser amounts of material. I'll be sticking blue tacks onto the bottom of each box, and I'll be weighing them to find out their mass. Using this weighing scale, I can ensure that the mass of each box will be the same, and the mass will not affect the results of the experiment. The only independent variable will be the area of each parachute, and all the other variables will be kept constant. Now, as you can see, I have placed blue tacks on the smaller boxes, so that now the mass of the smaller boxes is equal to the mass of the largest box, which is 14 grams. I will then be dropping the boxes from my ceiling to the ground, and using the timer, I will measure the time taken by the box to reach the ground. To make my results more reliable, I will drop each box at least 3 times and find the average using my calculator. The average will be the most accurate, and I can then compare the time taken between these 5 boxes and find out how the area of the box affects the time taken for it to reach the ground. There are 2 vertical forces acting on the parachute. One is the drag force, and one is the gravitational force. When the parachute is first released, air resistance below it starts at 0. Based on Newton's second law, force equals to mass times acceleration. When there's gravitational force and the parachute has mass, the parachute will definitely accelerate towards the ground. However, as the parachute accelerates towards the ground, air resistance below it will build up. Therefore, the drag force will increase. Eventually, the drag force will increase to the extent that it will be equal to the gravitational force, which will result in the resultant force being 0. If the resultant force is 0, the acceleration of the parachute will also therefore be 0. When the parachute has 0 acceleration, it will not accelerate at all, and the velocity of it will remain the same. Therefore, this parachute will reach terminal velocity. As the area of the parachute increases, the air resistance below it will build up faster, and the drag force will therefore increase faster. When the drag force increases faster, it will take a shorter time for the drag force to be equal to the gravitational force. Therefore, the bigger parachute can reach terminal velocity earlier than the smaller ones. We know that time equals to displacement over velocity. When the bigger parachute reaches terminal velocity earlier, the displacement towards the ground will be greater, and the velocity of the parachute during terminal velocity will also be lower than the velocity of the smaller parachutes during terminal velocity. Therefore, the time taken for the bigger parachute to reach the ground will be longer than the time taken for the smaller parachutes to reach the ground.